Figure 19.14 BinarySearchTest.java. In this example, we're going to demonstrate the binary search method of class collections. We start with our binary search test class here, and we've created at lines 10 and 11 a static final string array called colors once again, and you can see that initially at least all of these strings are not in sorted order. We also have a list variable of type string called list that we'll be initializing in our constructor. Now before we look at the constructor, let's just take a quick look at main, and at line 49 you see that we create an object of our class and then invoke its search method to perform the actual search operations in the example. When we create an object of the class, we initialize our list instance variable with a new array list of strings, and as we did in a prior example, we use the arrays class's asList method to get a list view of the colors array. Now in order to use the binary search method, we have to make sure that the array of strings, or the list of strings now, is actually sorted. So first at line 18 we invoke the sort method of class collections to sort the list, and of course strings are already comparable, so we are able to sort the list, and we then show you the sorted list here by displaying it in the command line. Main then invokes the search method, and repeatedly we invoke our print search results method, and we give it different strings to search for in the colors array. In the first three cases we search for specific strings from the colors array. In the last three cases we search for additional strings. In each call to print search results we receive the key. We also declare a local variable called result of type int and set it to 0. We display the key that we're searching for, and then we invoke the binary search method of class collections, giving it the list to search through and the key value that we'd like to search for. It then gives us the index number of the value if it can find it in the list. Otherwise it gives us a negative value indicating that the item was not found. We then print out, based on that, whether or not the value was found, and if so, show you the index number. Otherwise we tell you that the value was not found. So let's go ahead and run this example. And you can see in our output window that we're testing a number of different values. First we have our sorted list of strings, and based on that we can check to see if the results are correct. So initially we were searching for black, and it says it found that at index 0, which is correct. Then we searched for red, which was located at index number 4, the fifth element in the array, in the list rather, and you see red here. Next we searched for pink, and that was found at index number 2, the third element in the array. For the other values, aqua, gray, and teal, it returned negative numbers indicating that the values were not found in the underlying list data structure.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.